Welcome to Science Made Easy channel. A channel you will not want to miss.
Welcome to Science Made Easy channel. This is Science Made Easy channel and a channel you don't want to miss. So we will continue our Jamb syllabus today, and the next topic that we'll be talking about in our Jamb syllabus is chemical combinations. So chemical combinations. So don't forget to subscribe to our channel. So this is Science Made Easy. So let's talk about chemical laws and their verification. So we have about 4 chemical laws. The first one is what? Law of conservation of mass. And as you all know, the law of conservation of mass states that matter can neither be created nor destroyed during chemical reaction, but changes from one form to another. Now, there are some things that they use to verify this law to know whether the law is accurate or not. So they use a barium chloride and dilute H2SO4. So they mix the two something together. Even if you see a chemical equation, you see that for example, this barium chloride was not destroyed and did not even create anything. So what just happened is that it just transformed from one form to another. That means it was transformed from barium chloride to barium sulfate. It was transformed from barium chloride to barium sulfate. So it's not that the barium chloride was destroyed, and it's not that the barium chloride was created, but it transformed from the barium chloride to barium sulfate. So that is what John Dalton used to explain that for us. That is what John Dalton used to explain that for us. Although that law was later disapproved by some scientists using radioactivity, nuclear fission and nuclear fusion. But that is what Mr. John Dalton proved for us. And it's also one of the things that is also used to tell us about that is that the mass of the reaction, or the mass before reaction, is same as the mass after reaction. That means after you add VaCl2 and H2SO4 together, the mass they have before the reaction, and that is the same mass they have after the reaction. So we also have law of constant composition. Another name for law of constant composition is law of definite proportion. So law of definite proportion is telling us that all pure samples of the same chemical compound contain the same proportion by mass. So this one use water to explain to us, like any water, a pure form of water, they will contain the ratio of carbon to be 2:1. So the ratio of carbon of hydrogen to oxygen for every water is 2:1, unless the water is not pure. So if the water is pure, the ratio will go 2:1. That means all pure samples of a particular chemical compound contain the same proportion. You can't see water that contains 3:1 now. If the water is pure, it always contains the hydrogen to oxygen to be 2:1 if the water is pure. So that is what law of definite proportion is trying to tell us. So we also have another one, which is law of multiple proportion. So this law of multiple proportion is telling us that if element A and B combine together, it forms more than one chemical compound. And the several masses of one of them combine separately with a fixed mass of the other in a simple ratio. So the verification that they use to explain this one, for example, copper and oxygen can combine together, and if copper and oxygen combine together, it can give us copper 2 oxide, it can also give us copper 1 oxide. So that means when copper and oxygen combine together, it gives us more than one compound. So if a mass of copper reacts with a fixed mass of oxygen, and they react to give us more than one chemical compound. Even if our iron and oxygen combine together, if iron and oxygen combine together, normally it can have iron 2 oxide, we can have iron 3 oxide, Even we can have iron 4 oxide. So that means it gives us more than one chemical compound. So that is what they are trying to tell us there. So we have chemical combinations. Now, you would have been thinking, what's the purpose of chemical combination? Why are we combining two or more elements together? If all elements have a complete electron in the outermost shell, there's no need for chemical combination. But the reason why we introduce chemical combination is because many elements do not have a complete electron in the outermost shell. So the purpose of the chemical combination is for all elements to have a complete electron in the outermost shell. So that is the purpose of we combining two or more elements together to form a complete shell. So you can see the reason why, that is the reason why argon, all these our group 0 elements, argon, neon, helium, krypton, xenon, all the radon, all those ones, they did not participate in chemical combination. Why? Because they have all their electron complete in the atmosphere. Let me use this as an example now. Let me use neon as an example. This is the atomic structure of neon. Okay, we have an electron here, an electron here. We have an electron. Electron. Have an electron. So you can see for neon, all the electron, know that the maximum number of electron that the outermost shell must contain is 8. It's only this inner shell that usually contains 2 electrons. The remaining shell, they must contain the maximum that any element can contain in the outermost shell. The maximum number of electrons is 8. You can see that for neon, now this is neon. You can see that for neon, all the electron is what? Is complete. So there is no need for any chemical combination. The purpose of chemical combination is that so that all the elements can have a complete, they can form a stable structure. They can form a stable octet and duplex structure. So you can see this one now. There is no reason why this one will participate in chemical combination because all the electrons are complete. So the purpose of chemical combination is so that we can combine elements together. So we have two main types of chemical combination, which is the ionic or electrovalence combination, electrovalence bonding. Ionic or electrovalence bonding. So now electrovalence compound combination is also known as ionic, and I'll explain the reason why they call it ionic for us. So now talking about electrovalence bonding, it involves the transfer of electron from one atom, usually metallic. That means from one atom, usually metallic, to another atom, usually non-metallic. That means when we are talking about the electrovalence combination, is a combination between a metal and a non-metals. That means we combining one metal with another metals. And the reason we call it ionic is because most of the metals have a positive, they have a positive ion, and most of the non-metal has what? The negative ion, like Na and Cl now. So they call them ionic is because there's a transfer of ions. This one is giving out positive, on the number of ions going out from sodium is one positive ion and is one negative ion. So that means there's an ionic interaction. That is why they call it what? Ionic combination or ionic bonds. So that means electrovalence combination is between metals and non-metals. So how do we know metals? Metals always have a positive ions. They usually have a positive ion. So that means if you go and watch one of my videos where I explain atom, molecules, and ion, where I explain compounds, elements, compound, and mixtures, how you can form compounds together. Go and watch that video on my YouTube channel. You understand how we get all these ions more better. You understand how we get all these ions more better. So that means if we have atom and a metal combining with a non-metal, that is where we have our electrovalence combination. So normally sodium contain 11 electron, and our chlorine contain 17 electrons. Let's see. One thing is that if an element contains about 1 to 3 electrons in the atmosphere, the number of electrons that is going to form a duplex structure is 8. So if an element now contains about 1 to 3 electrons in the atmosphere, you can see far from it. It does not even up to half. So you can give it out. They can donate. That is why metals are donors of electron. They are donors because they have extra electron in the atmosphere. They can donate. So what happens here is that, like this sodium now will be donating. Like any element that has 1 to 3 electrons in the atmosphere, they can donate. For example, let me say that me and you that you are watching me now, I want to buy a land of 18 naira. You too want to buy a land of 18 naira. But you have about 60 naira. But I normally have about, let me say I have about 20 naira. So, and we want to buy a land. And me and you, we are friends. So, is it you that will give me the 60 naira or me giving you the 20 naira? But me, I will actually give you the what? 20 naira because my own money is still somehow far from where I'm going. I'm going to 18 naira. But your money is somehow close. So I can able to give you. That means at that point, me, I act as a metal. I donate to you. At that point, you act as a what? As a non-metal. What does non-metal do? They accept electrons. Now, non-metals contain about 4 to 8 electron. But we are not talking about 8 electron, 8 now because 8 is already complete. So it's contained about 4 to 7. That means once any element get to 5, it cannot donate again. Because it's almost 8. It's almost completing 8 already. So you'll be looking for someone to give him 3 more electrons. But if someone have 1 to 3 electron extra, he can give it out because 1 to 3 is still somehow far from 8. So anyone that has about 5 to 7 electrons in the atmosphere can still, that means that kind of people, they'll be looking for what? Someone to give. Someone that will give them extra electron. So that is where our electrovalence combination comes in. For example, now, our sodium. The electron structure of sodium is 2, 8, I'm coming, 1. And our chlorine is 2, 8, 7. So you can see, this one has 1 electron in the atmosphere. That means can give it out. Since it has about within 1 to 3. And it's still going to 8. It cannot kill on like it's here, you have 1 electron in the atmosphere and it's still going to 8. It's someone far. So you can just dash someone out so that E2 can have a complete structure. So for chlorine now, R7, it just means only 1 for it to complete. So what will chlorine be doing? He'll be looking for someone to give him 1 electron to complete. So that means if chlorine sees someone that can give him 1, that means chlorine will what? Become 8. But this sodium can give out this 1 so that chlorine the sodium can become 8, can have a 8 electron. For example, that is why we call this sodium Na+. Na+ means what? It will lose 1 electron because it has 1 electron extra in the atmosphere. It can lose it. We call chlorine Cl- because it needs 1 more electron to complete 8. At least chlorine now cannot give out of the 7. When it's just remain only 1 to complete. So that is why if this sodium now give out the 1, so sodium now become what? 2, 8. And what will now chlorine become? 2, 8. Sodium have given chlorine 1, 8. So that is what called what? Electrovalence combination. It's always a between a metal and a non-metal. So you have to know difference between a metal and a non-metal first before you can understand this topic very well. So that is why I said I should go and check one of my YouTube video. You understand how we can get what is a metal and which one is not a metal. So a metal usually have what? 1 to 3 electrons in the atmosphere, while the non-metal usually have about 4 to 7 electrons in the atmosphere. So let's combine them together. Like sodium now, 281. 2 electron is there. 2, Let me use this fluorescent electron to make it here. This is 2, 8, and it contains 1 in the outer atmosphere. That one electron is called the valence electron. So attached to these are sodium attaching to chlorine. That means dashing chlorine. So that means it's just that is dashing chlorine the electron. He's not benefiting from it. He just dash chlorine. So if you give chlorine one electron, so chlorine will be complete, and sodium will also be complete. So two of them will be complete together. But sodium is one dashing the chlorine. Chlorine is number 17. That is 287. So this 12, 13, 14. Even we can see it here, even without me. I think it's part of the note that I write here. Okay, but it's not well something in on that place. This 16, then 17 be joined here. So you can see the sodium on the you can see what happened here. Our chlorine is complete now. These are chlorine, it has complete, it's no free electron again. I need to check our sodium now. When it has dashed out the one electron, sodium to have complete. So that is what chemical combination do. So when the two elements combine together, both of them are complete together. So that is electrolyte combination. It is between one metal and a non-metal. So what example is what? Magnesium chloride. What example of the electrolyte combination is what? Magnesium chloride. That means you can see magnesium is a metal, chlorine is a non-metal. Magnesium oxide, calcium oxide, our sodium sulfide. So whenever you see a metal combined with a non-metal, that is what? A electrolyte combination. Electrolyte combination. You can see all the examples here. You have even lithium fluoride. Lithium fluoride is also another example. Lithium is a metal and fluorine is a non-metal. So combined together, it give us our ionic bonds. So what are the properties of the electrolyte compound or ionic compounds? They have a high melting and boiling point. So they have a high melting and boiling point. The electrolyte compound have a high melting and boiling point. They can conduct electricity. Do you know the reason why they can conduct electricity? Because they are ionic. They can conduct electricity because they are ionic. So for example, I told you about Na plus. So what happens is that once electricity is passed through the ion, they can conduct electricity in the form of a solution. That means when you pass electricity into them in form of a solution, for example, when all these our ionic compound, when they are dissolved in solution, they are breaking into ions. That is you still be taught under the ionic theory. That means when you dissolve them in water, they break into the ions. That means Na plus and Cl minus. N plus and Cl minus. So, and that gives a permission for electric current to pass through them because they will break into ions, and that gives you what? The electric current, the permission to pass through them. So for them to be able to conduct electricity. So they are also soluble in water. Why are they soluble in water? Because they are polar. They break into ions, Na plus and Cl minus. So they dissolve in water because they are ionic. And they are crystalline solid at room temperature. And they are made up of metals and non-metals. As I have told you before, they are made up of metals and non-metals. So let's now talk about the covalent combination. Covalent combination. So this covalent combination involves the sharing of electron. This one does not donate electron, it's share electron. That means it's not that I give you like sodium this to chlorine. This one will just say that give me and I give you. For example, I have sugar, I have gari, you have epa, you have coconut oats, you have granite, and I also have and you okay, and you have let me say coconut. So that means what will happen is that what I will give you gari and sugar. You have to give me coconut, part of your coconut and part of your granite. And I will give you what? Part of my gari, I give you part of my sugar. That means they are benefiting from each other. Give me and I give you. But talking about electrovalence is giving out, not collecting back. But covalent is what? You give me and I give you. You have this and I have this. I will give you part of my own. You also give me part of your own. That is covalent. For example, hydrogen, and when hydrogen combines together, and this covalent usually happens between two non-metals. Not like electrovalent. Electrovalent happens between what? Metals and non-metals. But covalent is between two non-metals. So when you see two non-metals combining together, you would have known as what is a covalent combination. It's a covalent combination. For example, when if hydrogen and hydrogen combine together, hydrogen normally is one, it has one electron. If it's combined with another hydrogen, the other hydrogen also have one electron. You can see both of them are complete. This one has two electrons, this one has two electrons. Because the first shell can contain maximum of 2 electrons. So both of them now have two electrons. So that means both of them benefit from each other. Both of them benefit from each other. So they both have 2 electrons now. So that means they are sharing electron. For example, ammonia, NH3. NH3 now. You know, your nitrogen is a non-metal, hydrogen is a non-metal. So when nitrogen and hydrogen combine together, nitrogen is number 7. That is 2,5. I'm coming. Another shell. 3, 4, 5. Now, and how many hydrogen? 3 hydrogen. No, this is it up to 5? 2. No, it's not up to 5 yet. Okay, no, 7. Nitrogen is 7. 2, 3, 4, 5, 6, 7. So this is nitrogen. Now we have 3 hydrogen. 1 hydrogen is attached here. So that place is complete. Another hydrogen, sorry. So another hydrogen is attached here. Another hydrogen is attached here. Another hydrogen attached here. So you can see all the nitrogen now complete how many electrons? 1, 2, 3, 4, 5, 6, 7, 8 is now complete 8 electrons. That means nitrogen 2 is now complete. Now, if you see the hydrogen 2, this hydrogen now contains 2 electrons, this hydrogen 2 electrons, this hydrogen 2 electrons. So hydrogen 2 is now complete. So you can see they benefit from each other. They are sharing electron between themselves. That means it's not that one is the one that is giving. Both of them are participating. Both of them are giving. That is covalent. So it's a between two non-metals. So we also have what we call the coordinate covalent combination. What are the properties of covalent compounds? They have a low melting and boiling point because they are not ionic. They are not ionic, so they have a low melting and boiling point, and they are not soluble in water, but they are soluble in organic solvents. The reason why they are not soluble in water is because when they are dissolved in water, they did not break into ions, so they did not dissolve. They cannot be break, so they did not dissolve. They will just stand by how they always stand. They just stand like that because If they are ionic now, they be break into ions, they can dissolve. But these ones, they just stand like that. But they can break, but they are soluble in what? In organic solvents. And they are gases and volatile liquids. And they do not conduct electricity because there's nowhere electricity want to pass through, because they cannot dissolve. So they cannot conduct electricity. So you also have the covalent on the coordinate covalence combination. Another name for the coordinate covalence combination is dative. Here, in this part, it's also exists between two non-metals, but there be an extra atom that does not participate in the combination. There be an extra atom that does not participate in the combination. I'm talking about the dative. There be an extra atom that do not participate, and that atom that does not participate, they call it a lone pair of electron. That means they say that one atom donates to a lone pair. That means there's one atom that does not. That means one atom donates a lone pair. A lone pair means it will make the compound to have what? Ion. It will make the compound to have an extra atom. It makes the compound to have what? An extra atom. For example, ammonia that I draw here normally is ammonia is complete already. If now add one hydrogen to ammonia, where will you put the hydrogen? There's nowhere you put the hydrogen here. That means it will give a what? A lone pair into this what? Into this combination of into this compound called ammonia. So for example, now the hydrogen cannot be here, cannot stay in any of the shell. So what will now happen? It now what? Donate a lone pair. That means there be a lone pair, a extra charge that will be on top of it. So like ammonium now, you can see it's ammonium now, NH4 plus. Is what? Is a covalent compound. Why? Because there's a lone pair. A lone pair, that means there's an extra atom in it. There's a charge on it. So that is what? Ammonium. Even we also have H3O plus. Our H3O plus, you can see it has a charge on it. Plus. That means there's a lone pair on it. H3O plus. We have H3O plus also. It's also what? A coordinate covalence combination. You can see it here. Our hydronium. So, and we also have other binding forces. So any compound you say an hydrogen is an hydrogen bonding. So this now that means hydrogen bonding is when what? Hydrogen is covalently bonded to an electronegative atom. So whenever hydrogen is bonded to an electronegative atom, the kind of bond that is in it is what? Is our hydrogen bonding. So, but different compound have the hydrogen bonding in different compound are different from each other. For example, the strongest hydrogen bond is in hydrogen fluoride. Why? Because fluorine is more electronegative than any kind of atom. It's the most electronegative atom. Fluorine is the most electronegative atom. So when hydrogen is bonded to fluorine now, that means the bond between them will be more stronger than any other kind of what compounds. The hydrogen bond in hydrogen fluoride is more stronger than another one because the fluorine is most electronegative. For example, now the hydrogen bond in nitrogen oxide or hydrogen in water is H2O and ammonia. That means the electronegative atom that is attached to ammonia is what? Nitrogen. The electronegative atom that is attached to water is what? Oxygen. But oxygen is more electronegative than nitrogen because if you go to periodic table, it will tell us that electronegativity increases across the period. Nitrogen and oxygen, they belong to the same period. But nitrogen comes before oxygen. But that means electronegativity increases across the period. That means oxygen is more electronegative than nitrogen. So that means the hydrogen bonding in water will be more than that of ammonia. So that means the strength of the hydrogen bonding depends on the electronegativity of that electronegative atom. So you also have a metallic group. So any bond bonded with a metal, they are bonded by what? A metallic group. They are bonded by a metallic bond. So you can see it here. So that means, the example, if you have UNACL is a metallic bond. Any compound you see metals, they are bonded by what? Metallic bonds. So you also have Van der Waals forces. This one actually happen mostly in gases. It actually occur mostly in gases. So it's a weak attractive force. The weak attractive force The weak attractive force in gases. So you can see they are used in liquefaction of gases. For example, iodine gas, carbon dioxide, nitrogen oxide, nitrogen gas. So the kind of forces that bind them together is a Van der Waals forces. It's a weak attractive force. So thank you. We'll be stopping here for today. Don't worry, in our next video I want us to do about 5 topics first. Before start, I will now move into past questions. We solve questions on past questions, Jamb past questions on the topics that are being treated. So thank you. Don't forget to subscribe. Science made easy love you. Thank you. Bye. See you in our next video. Don't forget to subscribe. Subscribe. Thank you so much. So we continue in our next video.